Welcome to BTEC Revision. In today's lesson, we're looking at Newton's laws. By the end, we should be able to apply Newton's laws of motion. Newton's first law of motion states that a body will continue to move with constant velocity or remain at rest unless it is acted upon by an external resultant force. For example, let's take this car. If this car is moving along with a thrust force equal to 10,000 newtons, and there is frictional forces equal to the thrust, so that's 10,000 newtons, then two things could be true. Firstly, this car could be moving with constant velocity, or it could be remaining at rest. Newton's second law states that the rate of change of momentum is directly proportional to the resultant force. If we were to write this in equation form, we can write this as F equals delta P for momentum divided by delta T, where T stands for time and delta stands for change in. If we remember, momentum is equal to mass times velocity, so we can replace P with mv. And if we assume mass to be constant, that would be able to take mass out of the change in to leave change in velocity. And if we remember, change in velocity divided by change in time is equal to acceleration. So that gives us the equation F equals ma. And this is linked to weight. Weight is a specific type of force. We can write that as W for weight, and that's equal to mass. But the weight depends upon gravity for its acceleration. So instead of multiplying by A, we would multiply by G. For example, if we have this car, 2,000 kilograms, that's its mass. So its weight is going to be equal to its mass times gravity. And if you remember from a previous lesson, gravity is equal to 9.8 newtons per kilogram. So we can replace this mass with 2,000 times 9.8 to give us a value of 19600 newtons. We can also say a thrust force of 10,000 newtons is propelling the car forward, and there is a very small frictional force, let's say 5,000 newtons. So we can say that the resultant force equals 10,000 take away 5,000, that's equal to 5,000 newtons. So this equation, Newton's second law, this F stands for the resultant force. So you would add up the forces. This is the sum of the forces. And as you can see here, for 5,000 going left and 10,000 going right, when we add them, we would take them away because they are in opposite directions. If we consider going towards the right to be positive, then left would be negative. So as you can see here, we have a positive 10,000 and we have a negative 5,000, and that would give us 10,000 take away 5,000, which equals 5,000. Now we have the overall resultant force of 5,000. Now we can plug this into our equation, F equals ma. Let's start by rearranging the force equation for acceleration, giving us A equals F over m. And we know the force is 5,000. We know the mass is 2,000. And that would give us a value of 2.5 meters per second squared. Newton's third law states that if body A exerts a force on body B, then body B will exert an equal and opposite force to body A. For example, let's take this car to be body A, and it is exerting a force down due to its weight, and let's say that is 10,000 newtons. And we have the road, and we'll say that is body B. Body B will be exerting an equal and opposite force to the car. And that would therefore be overall also 10,000. So the normal force is 10,000. Let's look at this example. We have a car that has a mass of 2,000 kilograms and is accelerating at 0.5 meters per second squared. Calculate the thrust from the engine. So if we can see, we have mass and acceleration. So what should come to mind is Newton's second law of motion, which is F equals ma. And we can simply plug in the values because the question is asking for thrust, which is a type of force. And that's equal to the mass, which is 2,000 times the acceleration, 0.5, and that would give us a value of 1,000 newtons. Pause the video here and attempt this exam question. Now we can see here, the car has a mass of 2,000. So let's start by writing that down. M equals 2,000 kilograms. And it has a frictional force. So we can draw a free body diagram. And frictional force is 2,000. And the thrust from the engine is producing force of 10 kilonewtons. So we want to convert that into newtons. So that's 10,000 newtons. Question is acceleration. So hopefully we can see what we need to do. We have to work out the resultant force, which is 10,000 is going towards the right, so that's positive, and 2,000 left, so that's going to be negative 2,000. So the resultant force, when we add them up, is 10,000 take away 2,000, which is equal to 8,000 newtons. So overall, there are 8,000 newtons of force acting on this car. The next thing we can do is write down Newton's second law, which is F equals ma. The question is asking for acceleration, so we're going to rearrange this to make a the subject, and that's equal to F divided by m. And this F is the resultant force. That's why we worked out the resultant force first. And that has a value of 8,000 divided by m, which is 2,000 kilograms, and that would give you the acceleration. So calculating that would give us a value of 4 meters per second squared.